Yes. All right. Shh. We're quiet now, please. So, to start out here, I have a square. What do you know about a square?
Four sides, also congruent.
Okay, relax. Okay, go ahead. It can be split in half to make two triangles. I heard you can, it has four sides and they're all the same, right? They're congruent. Okay, so I'm gonna label all four sides with that little dash mark, meaning that all those sides are congruent. Okay? I also heard that it has four right angles, right? So I'm going to put in these right angles here. Now, yes, I can split this into two triangles. So that's what I'm going to do next here. It's really not.
Yes, it is. I can't even know. Seriously.
No, whatever you did.
All right. It could do four, but I'm just going to do two. So, with this square, I create one of my special right triangles. Okay? So, if I take this diagonal and I go through this 90-degree angle, what is it going to do? It's going to make it a 45-degree angle. Okay, same thing with the other one right here. Okay, so instead of looking at this whole square, my highlighter shines really bright under this greenness, just so you're aware.
It's like a black light.
We're going to look at this right triangle right here. Okay? Specifically that right triangle there. I'm going to label. Shh, we're quiet now, please. I'm going to label my sides. So opposite that 90-degree angle would be the hypotenuse. Okay, the other two sides are going to be the legs. Shh, quiet, please. So my special right triangle is going to be considered a 45, 90 triangle. Okay, that is one of your special right triangles. And we're going to come up with rules to solve for the sides. Okay? Now, if I label, say this side is X, right? If I label that side as X, what does that make this side? What do these markers mean? They're congruent, so if this side is X, this side is X. So in a 45, 45, 90 right triangle, your legs are going to be the same. Okay? They're going to be the same length. Now I'm going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. Okay? So A and B are going to be your two legs, right?
Yep.
And C is going to be the hypotenuse.
Yep.
Okay, so I'm going to replace A with X and B with X. Just wait. Relax. I know. And I'm just going to say this is the hypotenuse squared. Okay, since C is your hypotenuse. Sorry. So, pay attention, please. So I can combine like terms now, right? Okay, so I have 2x squared is equal to the hypotenuse squared. Now to find this rule, this isn't normally what you would do, okay? So don't take this as this is normal algebraic steps here. I'm going to next take the square root of both sides. Okay? So what that does here is I'll have the square root of 2. Okay, it stays the square root of 2. And if I take the square root of x squared, that's x. Okay, so I have the square root of 2 times x. And if I have the square root of the hypotenuse squared, I end up with just the hypotenuse, right? Okay, now I labeled my leg as x, correct?
Yes.
So I'm going to come back here and say if I take the square root of 2 times the leg of that triangle, it will equal the hypotenuse length. Okay, so this is going to be your rule or equation for a 45, 45, 90 right triangle. Okay, so this is the one that you want to remember. I smeared it a little. And this is multiplication. Okay, so we're going to do some examples below. So again, I'm going to write out my formulas or rules here. So if I want to solve for the hypotenuse of my 45, 45, 90 triangle, I'm going to take the square root of 2 times the length of one of the legs. Okay, that's what we found above. Okay, that's why we can do this rule. Now say I already have my hypotenuse and I need to solve for a leg instead. Okay, your leg will be equal to the hypotenuse divided by the square root of 2. Now, you need to simplify this. So, if you do end up solving for a leg and it's over the square root of 2, you need to simplify that. You cannot have a square root in your denominator. Okay, and I'll show you how to do that when we have a problem like that. Okay, so here are your rules. Box them, do whatever you need to do so you know where they are, that you can look back at them. Okay, those are your equations or your rules that you're going to use. So looking at some practice problems. We want to find the value of x in number 1 here. So first thing I want to do is label my triangle. Okay? So opposite that 90-degree angle is the hypotenuse. And the other two sides are your legs. Now in this triangle, I have a 90-degree angle and a 45-degree angle. That means that other angle must be 45. Okay, so yes, I can use my rules for this problem. Okay, that means these other two sides I can call legs. Now I want to find the hypotenuse. So I'm going to look at the rule that says hypotenuse equals. And I'm going to use that one. Okay, and I'm going to plug in what I know. So I'm going to replace hypotenuse with x. Okay, then I have equals the square root of 2 times the leg, which would be 6. Now I'm just going to rewrite it so it's a little bit easier to look at. So I have 6 root 2 That's your answer. You're done. That's it. You don't need to enter it in your calculator. That's why these are special right triangle rules. You don't need to use a calculator. You already got your answer. All right. Shh. Quiet. Look at number 2. In number 2, both of these sides here are 9 times the square root of 2, right?
Yep.
That means they are congruent. Since those two sides are congruent, that means these two angles are congruent, so they have to be 45 degrees. So yes, again, this is a 45, 45, 90 right triangle. Now I can label my sides. So opposite that 90-degree angle is the hypotenuse. If you just write H, that works too. The other two sides are your legs. And now looking where that x value is. X is by the hypotenuse. Okay? So I need to find the hypotenuse. So I need to look at the equation that says hypotenuse equals. And I can replace what I know into that equation. So the hypotenuse is x. Then I have equals the square root of 2 times your leg value, which is 9 times the square root of 2. Okay, I can simplify this a little bit. If I have the square root of 2 times the square root of 2, what does that give me? 2. It gives you 2. So if I multiply the square root of 2 times the square root of 2, that would be the square root of 4. Right? What's the square root of 4? 2. So I can say this is 2 times 9. Okay, so I just combined those two numbers there. Now 2 times 9 is 18. And x will equal 18. All right, do number 3 for me.
Oh, God.
Do number 3. On your note sheet, do number 3. It's similar to the 2 problems we just did. Don't overthink it. You're just plugging things in to that equation. That's it. Don't need a calculator.
Oh, I was trying to find. Oh, I see what you did. Next one's different.
The next one is different.
What happens when you divide
He's like, why did you do it?
I do that all the time. I'm like, no.
All right, so looking at number 3.
Yeah.
All right, number 3. Again, we have this 45-degree angle here, so the other one must be 45. So I can use my same rules. Labeling my sides, I have my hypotenuse across and the 2 legs. Okay? Since x is by the hypotenuse, again, I'm going to use that top one because I want to find the hypotenuse. Okay? So replacing hypotenuse with x, I still have this square root of 2. then multiplied by the length of the leg. Well, the leg is 4. And I'm just going to rewrite it so it looks nicer. So I have 4 times the square root of 2. That would be your answer.
Got it right.
All right. Now the next 2 are a little bit different than the last 3 we just did. Okay? So in number 4, there are supposed to be those congruent markers on the sides there. Okay? So draw those in. Those are supposed to be there. It wasn't labeled. So since those 2 sides, quiet now please. Since those 2 sides are congruent, the angles are congruent. If your 2 sides, okay. So now I'm going to label across from that 90-degree angle is the hypotenuse. The other 2 sides are your legs. So I need to solve for a leg this time. That's where x is. So that means I'm using this bottom one here. So again, just like before, I'm going to replace what I know into that equation. So your leg is x. We have that equal sign. I know it's really hard to see because my stuff's way up here. Then I have the hypotenuse, right? The hypotenuse is 5 times the square root of 2. And then in my equation, that is over the square root of 2. Yes. Yes. So if I have the square root of 2 over the square root of 2, that's just 1, they cancel. So x will be equal to 5. All right. Number 5. So in number 5, both of my sides are labeled as x. That means they're the same. Okay? That means, again, this is a 45, 45, 90 right triangle. Labeling my sides. Opposite that 90-degree angle is the hypotenuse. The other 2 sides are the legs. And again, x is next to that leg label, right? So that means I need to use that bottom equation. So replacing what I know into that equation, your leg is x. That is equal to the hypotenuse, which is 12, over the square root of 2. Now in this one, that square root of 2 doesn't cancel, so there's something else you have to do to simplify it. So what I'm going to do, I'm going to multiply by a version of 1. Okay, so if I had 5 over 5, that would equal 1, right?
Yeah.
If I had pi over pi, would that equal 1?
Yeah.
Yes. Okay? So when you multiply something by 1, it's not going to change the actual problem. Okay? So that's what I'm going to do here. Except I'm going to multiply by the square root of 2 over the square root of 2. Okay? That'll equal 1 if you were to reduce it. But what I'm going to do is multiply straight across. So I'll end up with 12 times the square root of 2 over, if I multiply square root of 2 times square root of 2, is the square root of 4, which will equal 2. Okay? Can I simplify this further?
Yeah, if you're multiplied by 2, then it's 6.
Yes. So these both divide by 2 here. I can take 12 divided by 2, which is 6, and then I still have that square root of 2 there. And that would be your answer. Okay, do you understand what I did to simplify that?
Yes.
How I multiplied by what was in that denominator? Okay? And you have to make it a version of 1. There's lots of triangles in geometry.
Hold back, sorry. It's going to take forever, and then I'm going to have to.
You'll be okay. I promise.
It's going to be on the call. I'm talking.
All right. On the back. On the back. This time, at the top, I have an equilateral triangle. Okay, I know we didn't go over that yet, but you might know what it is. It's okay. It's okay. The sides are all equal. Okay, so I'm going to label. Hey, we're quiet, please. I know. It's just on when the rows are like this. So I'm going to label each side with that dash mark. Okay? That means all the sides are equal. Now in an equilateral triangle, all the angles are also equal. Okay? Those angle measures are each 60. Now, just like on the front, I'm going to split this into 2 right triangles. Okay? So I'm going to go straight down the middle. It's okay. When I do that, I create this right triangle here. Okay? And I'm going to highlight it again so we can look at it. All right, so that's the triangle that we're going to look at there. Now when I drew in this line, I split this angle in half. So that means this angle up here would be 30. Okay? So that angle in that triangle there would be 30. So our next special right triangle is a 30, 60, 90 triangle. Okay? Now what I want to do is label my sides just like I did in that square that I created a triangle from. So, opposite that 90-degree angle is always going to be your hypotenuse. Okay? Now, instead of labeling both of those sides as legs, I'm going to label one of them as the short side and one of them as the long side. Okay? So opposite your 30-degree angle, since it's the smallest angle, will be your smallest side. So if I go from 30 to that next opposite side there, that's going to be your short side. Opposite from your 60-degree angle to the other side will be the long side. And yes, I know the hypotenuse is longer than that side, but the hypotenuse is called the hypotenuse. So we're calling that other side the longer side of the two legs. Okay? That's why it's called the long side. All right. So we do need to make up a rule just like we did on the front. Now I'm going to label this short side here as X. I'm going to label the long side Y. Okay, they are different lengths. Okay, so we have different variables. Again, I'm going to use the Pythagorean theorem. Okay, so we're using a squared plus b squared equals c squared. Okay, for now I'm going to plug in what I know. So a and b are your short and long sides. Okay, so I labeled my short side as x and my long side is y. And c is going to be your hypotenuse. Now, before I continue, because there's not really much I can do right now, right, in that equation? So, looking back at the entire equilateral triangle, not just the highlighted one, what did we know about all of the sides? They're equal. So, I have my hypotenuse right here. That would be the same length as this side, right? Now, since I split this into two right triangles, wouldn't this length right here also be considered x? Right? Now, this whole length here would be 2x. Okay, I just added those two sides together. Now, we were working with an equilateral triangle. So, isn't this side equal to the hypotenuse?
Yeah.
And I just labeled that as 2x. So your hypotenuse can also be labeled as 2x. You see where I got that from? No? So this right here was x. So this right here has to be x because I split it in half. To get this entire side, I added them together and I got 2x. Now in an equilateral triangle, all three of these sides are going to be the same. So since this is 2x, this would be 2x, and this side would also be 2x, right? Okay, so that's where I got that 2x from. So now instead of saying hypotenuse squared, I can say 2x squared. So I'll still have x squared plus y squared equals, and now I'm going to replace hypotenuse with 2x and square it. Okay, I want to simplify this part right here before I do anything else. So I still have x squared plus y squared is equal to, I'm going to distribute that square to both numbers. Okay, so I have 2 squared is 4, and x squared. Okay, now I can combine like terms. So I'm going to subtract x squared from both sides. So I have y squared is equal to 3x squared. Now just like on the front, I'm going to take the square root of each side. Okay? When I do that, I end up with y equals square root of 3 times x. Now I labeled my long side as y, right? So I'm going to replace y with long is equal to square root of 3 times x was short. Okay? So square root of 3 times short. This is the rule we're going to work with along with that short side and that hypotenuse. We can figure out that hypotenuse by multiplying that short side by 2, as seen by that x and 2x, right? Okay, so we have a couple different rules for this one. So looking at these bullet points here, these are your rules. So if you're looking for the hypotenuse, you're going to take 2 times the short side. Okay? And if you're looking for the short side, you're going to take the hypotenuse and divide it by 2. Okay, so there's 2 rules right there. To find your hypotenuse, you can take 2 times the short side. To find the short side, you can take the hypotenuse and divide it by 2. For the long side, that's equal to the short side times the square root of 3. That's what we found here. Okay? Now if I want to find the short side, and I'm given the long side, I can take the long side and divide it by the square root of 3. And again, we need to simplify this if we end up with that square root of 3 on the bottom. All right, going through number 6. Okay? Number 6. First thing I want to do is look at the angles in my triangle. I have a 90 degree and a 60 degree. That means the other one has to be 30. Okay? Now I want to label the sides. So opposite that 90 degree angle is your hypotenuse. Opposite that 60 degree angle is which side? The long side. And opposite 30 will be short. And you can use L, S, and H if you want to. You don't have to actually write up the whole word. So I have 2 variables here. I need to find the short side and the hypotenuse. Okay? I am given the long side. Okay, which one of these do you want to solve for first? Short side? Okay. Yes, you're going to solve for the short side first. Okay? If I tried to solve for the hypotenuse first in this one, and I said, oh, hypotenuse equals, well, it's 2 times the short side. Well, I don't have the short side yet, so I can't plug that in. Okay? The other equation with the hypotenuse in it, well, I still need the short side. Okay? So that means I need to find the short side first. So I need to look for where it says short side equals. Okay? So that'll be this one here. So now I'm going to plug in what I know just like I did on the front. Okay, so short side is x. That's equal to the long side, which I have is 15, over the square root of 3. Okay, and I want to simplify just like I did on that last problem on the front. So I want to multiply it by a version of 1. Okay? So I'm going to multiply by the square root of 3 over the square root of 3 because that's what was in my denominator. Okay, then I can multiply straight across. So I have 15 times the square root of 3. Now if I have square root of 3 times square root of 3, what's that going to give me? It'll end up being 3. So if I have 3 times 3, that's 9. Okay, that's the square root of 9. And if I take the square root of 9, I get 3. And then I can simplify this further to get 5 square roots of 3. So I'm taking 15 and dividing by 3. So I found the x value here. Okay, now I want to find y for your hypotenuse, so I'll look to see which one says hypotenuse equals. Okay, and that's this one. And I'll replace what I know. So hypotenuse is y is equal to 2 times the short side. Well, I found the short side right here. So I'm going to multiply by 5 times the square root of 3. I can simplify this one step further, so I'm going to multiply those two numbers out front of that root to get 10 square root of 3. Okay, questions on that first problem we did? Yeah. It's okay. No. I do want you to try at least one of these 3 problems. Though. One. Try one of those 3 problems. No. 7, 8, or 9. Do one of those problems and bring it back tomorrow. Okay?